Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Okay, and Selamat Hari Raya to all Muslim. Okay, sorry. So today we will continue our lecture into chapter 9, which is operational amplifier, or we call it as op-amp. Okay, so okay, basically op-amp we will use it as a voltage amplifying device. Okay, so inside the op-amp there is some external components which is such as resistor and capacitor, which is between the input and output terminal. Okay, so this component will determine the output of that we want to the op-amp to be function. Okay, so in op-amp basically there are 3 terminal device which is consists 2 high impedance input, which is one of the input we call it as the inverting input. Okay, which is, if you can look at this figure, okay, we call it the inverting input. We mark it as a negative sign, and another one is non-inverting input. We mark it as the positive sign. Okay, so what else? Okay, so there are 5 characteristics of op-amp that we need to know, which is the first one is the open loop gain. Okay, so the main function of the op-amp, we know that is the function of this one is to amplify the signal, right? Either we need to amplify the current or we need to amplify the voltage, right? So the for it to be best or to be good to be function, it must have to be more open loop gain, so it's much more better. Okay, so the open loop gain is the gain of the op-amp without positive or negative feedback, and for such an amplifier the gain will be infinite, but in the real situation the op-amp the value of the gain is in the range of 20,000 to 200,000. Okay, the second one, the second ideal characteristic of the op-amp is the bandwidth. Okay, it should be infinite bandwidth. Okay, so in ideal operation of op-amp, it has an infinite frequency response, and it can amplify any frequency signal from DC to AC to very highest value of AC frequency, so it is therefore assumed to have an infinite bandwidth. Okay, but in real op-amp the bandwidth is limited by the gain bandwidth product, which is equal to the frequency where the amplifier gain becomes unity. Alright, the third one is it should be the infinite. Okay, there is some correction here. It should be infinite input impedance. Alright. Okay, so what is the input impedance? Okay, input impedance is the ratio of the input voltage to the input current, and it assumed to be infinite to prevent any current flowing from source supply into the amplifier input circuit. Okay, so but in real op-amp there is some input leakage current in between picoampere to the few milliampere. Alright, so the last one, not the last one, the fourth characteristic of the op-amp is the zero output impedance. Okay, so the output impedance of the ideal op-amp is assumed to be 0. Is acting as a perfect internal voltage source with no internal resistance. Means that there is no internal resistance inside the op-amp, so that it can supply as much current as necessary to the load without the interruption by the internal resistance. Okay, so the last one is the zero offset voltage. Okay, so what is means by zero offset voltage is that the amplifier output will be zero when the voltage difference between the inverting and the non-inverting input is zero. Means that if the difference between here is zero, the output is zero voltage, and then the output should be in zero voltage. Alright, so that's the 5 characteristic of the ideal characteristic of op-amp. Okay, so this is the last slide. If you can see, is the equivalent circuit of an ideal operational amplifier. So this is the inverting input, this is the inverting input, this is the non-inverting input. Okay, inside the op-amp there is some resistor, and then this is our output terminal on the op-amp. Alright, so I will continue the lecture into part 2. See you there. Thank you.